Hello, everyone. Today is October 7th, 2020. This is the Kubernetes Data Protection Workgroup meeting. So today we have quite a few things on the agenda. So let me share my screen. So just I want to quickly go over some of the caps that are in review or being merged currently for the 1.20 release. And then we can talk about the data protection workflow whitepaper. So there are a couple of work streams that are going on. So we'll see how much time we have. And we'll just cover as much as we can. So for 1.20, the enhancement freeze, which is cap merge date, was yesterday. And then code freeze is November 12th, which is 1 month away. So there are quite a few caps that are relevant to this data protection working group. So that's why I listed them here. Snapshot. So we are trying to bring Snapshot to GA in 1.20. Cap got merged. So that's good. But then we actually still have a lot of work to do to meet the code freeze deadline, which is 1 month away. We need to write quite a few E2E tests. So I listed these 3 tests here. I'm actually looking for some help. Right now, those 3 tests don't have any owners. So if you are interested and if you have some time to work on them in 1.20 release, please let me know. And then the next one is container notifier. So we were trying to bring it to Java, but we didn't make it. There are some issues that we still need to get resolved in our design. So I listed a couple of them here. I just want to talk about them briefly and see if there's any comments from you guys. So so the container notifier, we are trying to bring in this as a pod inline definition for us to define what kind of command we can run in the container. For our use case, it is quiet, non-quiet, and then also a notification API object that is for an external controller to request the container notifier. So basically, you request what command you run in the pod. So there are a couple of things that that we have some discussions in that cap review. One thing is how to decide what pods need to be selected for this QoS. And initially, we have this pod selector there. So if you have the selector, then it's going to select the pods that meet the criterion. But I think if it's a selector, then that means the controller, so the backup controller who is actually running this, requesting the QoS, wouldn't know ahead of time what pods are selected, because the pod is going to be this kubelet, or in the first phase, we're going to have this central controller, the container notifier controller, which is the one that is deciding what are the pods that are selected. So, which I think it's really not going to be practical for the, especially for the QoS use case. So, so I'm thinking that either we can use a pod list, which is more deterministic. Basically, a backup controller would be the one who can use a pod selector or some other ways to determine what are the pods that should get this QoS command, and then in this notification object, we just have a pod list instead of a pod selector. And then there is another concern, which is the status update. Right now we have because initially we say we want to have this pod selector. So now if we say we have a pod list, still there could be a lot of, basically you are getting the status update for all the pods and all the containers. That's a lot. So there's some concerns on the scalability. So for that, if we're using pod list, I'm thinking maybe we need to do update using a slice of pods. So the details, I don't really have any details on that. There's some similar proposal for the endpoint slice. So it's going to be similar to that. This is just something that I'm thinking. And then another idea is to actually have a one-on-one mapping between pod and notification, so that we will just send one request at a time for one pod instead of sending a notification for a list of pods. So this way we'll simplify the status update part. Yeah, so those are the things that we still need to sort out. I don't know if there are any comments on this. Okay, so yeah, I listed the cap there, so you can take a look at the cap. I need to update that and with these proposals. So right now we have pod selector. So I'm thinking that I will just write down all the alternatives and what are the corresponding status update that we need. If we use either pod, it will be straightforward, or a pod list, maybe we need to have a slice of a pod slice or something, which might mean that we need another API object for that. So I have to take a look up the endpoint slides and see how that is defined. Okay, so that's that. So if you don't have any questions for the first two caps, I move on to the generic data populator. I wonder if Ben is here today. Doesn't look like he's there. Okay. Yeah, so Ben is actually working on this generic data populator. Initially, we were thinking about bringing it to beta, but I think when we're going through this production readiness review, now the cap have this new requirement for production readiness reviews. Actually, the snapshot cap went through that. So Ben realized that, okay, so he's going to introduce this validation webhook for the data populator, to making sure that it is something, it is like a registered external data source rather than anything. So for that, we actually would need one more release. So I think right now he wants to keep this in alpha in 1.20. So that's the status for this one. And then the next one is the Cozy. I don't know if anyone from Cozy team is here. If not, I will just quickly talk about it. This is to have the Kubernetes API to be able to provision object bucket. So there are actually weekly meetings on that. So the plan is to get the cap merged as provisional, so that we can start to do POCs, having code ready, and then getting ready for the next phase, which is to bring it to alpha. So 1.20, this will stay as provisional and doing POCs. I think the cap is not merged yet, but I think because this is provisional, so we are actually does not have to be getting merged strictly by this deadline. If it's alpha, then we have to meet that deadline. But since it's provisional, so we actually can merge this one after the deadline. So hopefully we'll get that cap merged soon. So that's a quick update of all the caps that are going on. Any questions so far? Okay, if not, then we'll move on to the data protection workflows. Is Fong here today? Okay, I don't see him here because I actually would like him to go over the application workflow because he added some update for the backup and restore workflow there. If he's not here, then I'm going to maybe talk about the CBT. Okay, I can talk about CBT. All right, so this is the one of the things that we are talking about. We had one meeting to discuss this. This is a really just a pretty early discussions, but I want to get more feedback from this group here. So so we talked about why we need CBT in Kubernetes. So we listed a few use cases. So the first one is backup. For backup, before we talk about CBT, we actually need to talk about backup in general. So currently we do have APIs in Kubernetes, Snapshot APIs, but that does not really have any definitions in those APIs to say whether we want to back it up to a different location or not. So that's not there. So Andrew actually had a Google Doc on this. He actually talked about this in one of the very early meetings that we need to have backup APIs to handle this. So yeah, so the first one is to, in order for backup vendors to support this, we will need to be able to back up data to a different a secondary storage that is not your primary storage. So that's the first one. And then, so what do we do if we don't have this? What is the currently what do backup vendor do? So currently we can have a data mover pod. So and then basically after taking a snapshot, we can create a PVC from the snapshot and mount that to the data mover pod, and then move data to a secondary device away from your primary storage. So that's for the backup. Why we need this, and then also for backup, if we are always taking the full backup, then the concern is, of course, is not space efficient. It takes longer. So, and also there are, even though there are cloud providers that are providing ways to do incremental snapshots, but that only works if it's on the same storage, right? So it's all AWS, so it's going from EBS to S3, it's handled underneath. But if we want to back up this data to a different storage device, then this is not going to work. So we do need to have a CBT. So here listed.
Is the plan to have the CBT as a as part of the CSI spec, or
So we haven't get to that point. So this is right now I'm talking about the white paper part. So in the white paper, we talk about why we need it, right?
Okay.
So I think we need to list out the reasons why we need it, and if without it, what is the workaround? What are we doing? So that's why we have this section here saying that, okay, without that, what do we do today, right? So I think Fang actually added this one saying, either we have to always do full backup,
Right.
or
Communicate with the APIs to get the CPT.
yeah, so otherwise we will have to directly use the storage API to get that information. Right. So yeah. So I think the problem is that then that means the state more part will need to be dealing with different APIs. It's not a common API. So I think that's what's listed here. So yeah, do you see any other things that we should add in this over here? So yeah, so basically that's the thing, that's the workaround. If we don't have this, then you just need to have to deal with this individually. Okay. Okay. Do we have any other use case that we want to add, or any other reason that we should add here, saying that okay, we need to have a common API for this? Or do you guys agree that this looks good?
And this looks good from my end, at least.
Okay, thanks.
Sorry, Shing, the part I don't understand is,
yeah.
So if a storage vendor supports incremental backup or incremental restore,
yeah,
then here we're talking about exposing that functionality through CSI.
Yeah, so we haven't got that point. So basically, okay, so here is the thing, right? So if you actually have everything, so for example, just use the AWS, for example, right? So it already automatically take incremental snapshots. So, but in that case, this is basically all AWS, right? So AWS, they take care of this one internally, that's fine. But what if we want to back up this data to a different storage device from a different vendor, right? So third party backup vendor, right? Not AWS, right? So that's what do we want to do here, right? If you want to support a variety of storage, you want to be able to back up from different storage vendors and back it to your storage device, which is not the same as the primary storage. What do you do? I think that's the question here, right? If you handled everything underneath, I guess that's, yeah, then you don't need it because you have your API, common API handle this, right? So here we are talking about, if you want to back this up to a different location, a different storage device, then you would have to use that storage vendor's API to do that. Or you can probably come up with your own, maybe a common, you maybe have your own common API to look at the diffs. That's also possible, right? That's also possible too.
I mean, I guess the part that's hard for me to comprehend is like, what's the incentive for on-prem storage vendors as well as cloud storage vendors to expose these changes, incremental changes through an API?
Yeah.
And
so,
do any of the hyperscalers provide these APIs?
So we actually have not really get to the details of the API part yet. So just right now we are looking at the reasons, right? Why we need to do this, what are the workarounds if we don't have this. So I think when we talked about this last time, I think there was someone was saying,
yeah. So Sheng, yeah. Azure for Azure Disk, that those APIs are exposed.
Okay. Yeah. So we actually, if you go to
Azure, AWS, I believe the APIs are there. I mean, it's not part of Kubernetes directly at all. You know, through their controllers that they're building for Kubernetes, you can still access them in a way.
So yeah, so basically, if you look at the who supports, so we have a section to say who supports this, right? So this is a section that I need input from all of you. So we have AWS actually have that.
Mm-hmm.
They expose this, and Azure have this, but I think I see this Lexi saying that the links we listed here does not really does not list the change blog API. This is just some introducing this support. So if anyone knows some API and is there a link to the API that we can add here? Yeah, please just add that information here if you know. And for Google, I think this is a work in progress. They don't have it yet, but they are working on it. Right, so we do know at least, this is 3 cloud providers actually either have it or working on it. Yeah, the Cinder is the little different. Cinder doesn't have CBD, but it actually has a full backup service that does incremental backups automatically. And then VMware, we have those for vVols. Is Dave here? Dave's not, okay. Yeah, so yeah, so this is actually an API. So every storage vendor that supports vVol actually already implemented those APIs. So yeah, so that's already a common API for different storage vendors that supports vVol. And then, we have other vendors who support this, right? So if you know any other storage vendor that supports this, please go ahead and add them here. Yeah, I think there are probably a lot.
Okay, can I ask the clarifying questions? So like,
yeah, of
these
course.
Vendors that support incremental snapshots, like, are these snapshots portable such that they can, for example, like a vVol snapshot can be converted into a non-vVol volume, or are these just lets you store a vVol snapshot on an arbitrary storage backend? Like
oh, so those are
part of the is the effort to have portable snapshot formats or not?
So those are different APIs. So I think the API, how do you have a common API? That's the next thing that we want to discuss, right? So right now we just want to say who actually have this. And then of course, I think it's going to be a challenge to if we want to say, okay, let's have the API in Kubernetes just for this, and what does it look like, right? But I think vVol is one example because it actually have multiple storage vendors that supports that, right? So that's one example. I'm not saying, of course, it's not going to be exactly the same as that. Is the way you express API is very completely different in this word, right?
Sorry, I'm late. Jing, I think you can add a little bit on that one. So I did I do research on these CBT these, and generally the component are similar. Like for each of the chain block, each of the description, you will have like an offset and what the length of the data that is changed in that blocks, and you have and then they specify like a multiple in an array. So in general, they are in that format. In detail, like each of them maybe have a little bit here and there, a little bit different. Some of them do not, instead of spell out the exact length, they would have a fixed length, and then they have a bitmap. The detail a little bit different, but I think it can easily convert from one another without losing the details. That is for block device, and for the file system device, there's also a similar concept, but it specifies the file that change. And then you can have, like, for example, in the struct of like a struct list, each of the item in the list for the file, it will specify the file path. the stats of the file, the OS stat of the file, like, you know, file mode, what type of file it is, access time, recovery, and so on and so forth. So these are, in general, they have quite a lot of similarity between them. I cannot say I can look at all of them. I look at some of the API that being provided, or some of the you know, internal from the LEMC API that not being exposed outside yet. So I look at them and I see a lot of common. So I think in our next step, when we have a meeting again, we will dig down into like how can we extract these common API, these into a common API to use. But that is the topic for maybe the next meeting, I guess.
Okay. Yeah, so yeah, if you can also just add some here in the doc after the meeting, that would be good. Okay. Maybe I can I assign this part to you? You can add something here?
Yes, please assign to me. As a matter of fact, I already have a document ready to be shared in our last meeting. But then we stop. We just say, "Hey, let's just talk about the reason for now." But I do have the info.
Okay. Sorry. What is your email?
HOANG is the last name.
HUO.
It's okay. I can
Okay, you
I
can
can talk to you offline. Yeah.
Okay. So yeah, so please you know, add to the list if you know other storage that has the support. Add to this list. Okay, so going back to here. So Alan, does that address your concern, question?
So it seems basically the goal, like one of the end goals, is to have a portable snapshot format such that if a storage vacuum supports incremental snapshots, those snapshots can be backed up to any arbitrary vacuum, not necessarily of the same type as primary, but to any vacuum.
Yeah.
That seems to be part of this effort, right?
Correct.
We want to have portable snapshots.
Yes.
To enable volume-to-volume migration. Look, let's say volume A is of one type, let's say VVol, volume B is a different type, let's say EBS, and that can happen. Is that part of the end goal?
Yes.
I think we already do some of these portable when we create the in the CSI PV and PVC, right? When we backing up a PV, we can backing up from any storage vendor.
Right, and then so basically you can back up and then store at the same storage device, basically, right?
We have portability of volume data today. This would add portability of the snapshot implementation so that you could literally switch your volume provider and keep your snapshots in theory.
Okay. So, and then, okay, then continue with the restore. Restore, basically, I think this really depends on the backup part. At the restore time, we would still need to do a full restore first, and then layer incremental restore on top of that from the incremental snapshots. And then, and also partial restore. What is, okay, so this is not strictly related to CPT, right? I forgot who added this case. I mean, yeah, partial restores is like you select some files.
So this is a little tricky because the way most implementations do incremental restore or partial restore is based on data access patterns. So this is something in the data plane. So CSI or the control plane is completely out of the loop. And I don't know exactly how CSI is going to do smart incremental restore, given that it's just a control plane component.
It's not incremental, it's partial, right? Like if you had a
partial
block
or whatever.
You could restore a block range, or if you had a file system volume, you could restore a directory. Yeah, like CSI would have to become aware of things like block ranges and directory names.
So the thing we need to think about is I don't want CSI to do all of those work. This should be handled by the backup vendors. But when you think about how to do that, yeah, haven't really thought about this restore case yet. I think it's the backup vendor will need to be.
This is a little tricky.
Yeah.
Even if we supply some arbitrary range to CSI, but, you know, let's say blocks 1 to 100 get fetched by CSI, pre-fetched. What if the application tries to access block 200? So there is a, you know, there is a disconnect between what the CSI may do or what the application needs as far as data access.
Yeah, the restore is a little bit more complicated. To depend on you restore to a completely new, or you restore on something is running right now, right? And then when we do restore to a development in a production environment where we have some pod is running and using that persistent volume, things are much more complicated than just that. And I don't think it's allowed to being right to some PVC that currently is using by a specific pod. I mean, by some pod. The reason is that I think the volume, when you create a PVC, you create a mode of, I think you have to specify the mode of write read many or write read one. If you have a wrong permission there, then only the pod that currently is using that PVC can accept that PVC. And if for that case, I mean, you cannot, the backup storage cannot even do anything with the pod that is with the PVC that currently being used.
Yeah, I think it's I need to think about this one more actually. Yeah, maybe this one. I'm not sure.
I think we need to discuss a little bit more.
Because when I was thinking about this, I was actually thinking about what we did from Cinder program. But Cinder actually has a complete backup service itself. It's on the data plane. It's a little different. So you think about how this is done if we are only providing those APIs.
But it still has some use. For example, if the user agree that for example, if I deploy a stateful set, right, and even though it's in the production, if the user allow me to scale down the stateful set to 0, which means that effectively remove the pod, but still the PVC is still there, then I can do partial or differential restore a few blocks there quickly, and then restore the scale back the stateful set to whatever the current the previous number is, and that can be a good production restore with the incremental restore. But we have to accept that the pod have to go away for whatever period of time. It's still very quick compared to restore the entire new namespace with a new PVC, but it's still, I mean, that is something that is possible. But I agree that we need to think about this a little bit more.
Yeah. Yeah, okay, this one's a question mark. Yeah, need to think. So this one I forgot who mentioned. I does not look like this is directly related to CBT, the partial. You're saying that it's still related because they probably already have something there just to do incremental. Okay.
Right. So this is like pulling a single file out of a previous snapshot, if you will. That maybe you just destroyed a single file in your volume and you want to restore that.
Okay. So it's more relevant for file rather than block. Okay.
Yeah, I think David or someone in our meeting mentioned that this incremental backup, the efficiency of having a CBT mainly for the backup side, I'm not sure if it much benefit on the restore side. It's mainly for the efficiencies in the backup, because we do backup more frequently, like every day or every few hours. Restore, not that much. So not sure.
Right.
Yeah.
But then how do you do restore? You have those backup. If user want to pick the incremental backup, do you restore? Then what do you do? So that's you would still need to figure out.
Oh yeah, the backup image actually is a synthesized image of the full backup, right? It looks like a full backup all the time, but we only even though we only get the change, but in the backup storage it should be a full backup, so you can restore every single time using that synthesized full backup image.
This is a problem for the backup provider to solve. Like if you put change block tracking
exactly.
in CSI, everything else just becomes an implementation detail for the thing that does backups and restores.
All right. Yeah, this is what I was trying to figure out. If it's if it can completely handled by backup vendor, then that's not a problem. I was thinking if CSI needs to do something, then that's really weird. Yeah. Okay. Okay, and then there's also a use case here for snapshot-based replication. And hey, John, since you are here, I think John's, yeah.
Yeah, I'm here.
Yeah, you want to go over this since you added this use case?
Yeah, sure. So the idea here is being able to use the change block tracking as a mechanism to implement via some higher level controller asynchronous volume replication, potentially between two sites. So what you could do is periodically take that diff and ship it to the remote site. So you're then getting, an efficient change list basically between two snapshots from your source, and then applying that on the remote site. And so this obviously isn't useful for synchronous replication, but async replication is a commonly used thing, and this would allow vendors to build this facility fairly efficiently.
Do you have this implemented for Ceph?
So Ceph, yeah, I mean, Ceph does, the RBD driver does do snapshot-based async replication. But obviously that's not, the change block and stuff is not exposed at the Kubernetes level. It's also limited to mirroring Ceph RBD to Ceph RBD. And so, like a lot of what we're talking about here, if we want to do or allow these diffs to be portable across storage backends, right, we need to standardize that interface and expose it.
Mm-hmm. Okay. But you do already have the CBT APIs for RBD already. Okay.
Yeah, I put a link down lower in the document, I believe.
Oh, yeah. Okay, great. Okay. Right. Okay. So yeah. So then, if we don't have this, then it has to calculate manually each time between the source and destination. Then it's going to be difficult.
Yeah. So for stuff like file volumes, you can basically use rsync. Mm-hmm. But block volumes, there's really nothing for an application to look at other than the individual, block data.
Mm-hmm. Okay. Okay. Any questions for this use case?
So John, is this predominantly an optimization to reduce the amount of incremental changes that we transfer? Or is this, look, you're actually looking at this as a separate workflow?
So by putting the, or by getting the changes directly from, to be exposed directly by the storage system, it would, like say in the case of file volumes, allow us to skip the metadata scan before sending, right? So that for a file volume. For a block volume, you know, there's really no good way to do it at a higher level. I don't know if that was what you were getting at or not.
So basically, like, are we looking at continuous async replication as a workflow that is triggered by the users, so like through Kubernetes APIs, or is it just some process that happens in the background just to make incremental backup transfers more efficient? So because the deltas are now smaller. Does that make sense?
I guess I think there's two parts to that, right? One is kind of the interface of what gets exposed at the Kubernetes level. And, you know, yes, I think it would be great for us to have some sort of interface, probably not, you know, not something sort of standardized in the SIGs, but allow a vendor to produce an async replication controller, right? That would allow you to configure async replication cross-cluster, within cluster, you know, cross-storage system, whatever, you know, the user wants to do to meet their data protection requirements, and, you know, do that in a standardized way. Now, the other side with respect to the efficiency of it, you know, there's certainly nothing standing in the way of today for a file volume just using rsync to implement that feature. But it would be made even more efficient by allowing you to, by basically making it so that you didn't have to do the metadata scan, right, that rsync is doing. If you could get the change list directly from the storage system.
Well, isn't there also the issue of being able to read a snapshot? Like today, Kubernetes doesn't give you that. So is that part of the proposal? To be able to like
yes, I believe
directly
so.
read snapshots without cloning them to a volume?
But that would require mounting the snapshot, right?
Well, I
That's
mean,
what you're talking about?
if you wanted to do an rsync type thing, yeah, you kind of need to mount the snapshot. Or if you want to do a metadata scan, you're in the same boat.
So yeah, if you're doing it manually today, yes, you do need to take the snapshot, turn it back into a volume, you know, attach it into a pod, and, you know, go from there. So yes, that is kind of inefficient today. If we get the change tracking, you know, I don't think we've gotten to the point where we figure out how we actually get the data out, right? We haven't talked about the APIs yet. But I think one of the benefits would be that you wouldn't need to create hopefully wouldn't need to create a whole new PV from these individual snapshots in order to read the data out. Yeah,
what I'm getting at is like being able to directly read snapshots is a necessary but not sufficient component of what you're asking for. So like you could treat that as step one.
But is that necessary though? If we have CPT, then we shouldn't.
Yeah, because you still need to read the blocks or the files once you know which ones have changed in order to back them up.
But then you're supposed to be able to get that from the storage vendor, right? You just ask for those.
The point of doing this in CSI is to provide a generalized interface so that anyone can do it. And then there needs to be a generalized interface to read the files or the blocks.
So if you're talking about, if be able to mount, I think that's like an additional one. I know that one we actually, I don't know if we still have that in a chart. I know I have that somewhere at one point. So that's like a new, this is actually another feature, I think.
Actually, that's the very good point that whether the CBT that we are talking about is only contain the description of the chain, like, you know, the offset and the offset and the length of the chain, or it actually contains the data that it changed. Like, for example, if the chain is 200 megabyte, then does the CBT provide the actual 200 megabyte of data chain itself, or just saying it offset 200 and the length is 200 megabyte? So that is.
I would think you would want the latter, because then you could implement just snapshot reading and leave the change block tracking up to some other application like Async to figure out, and then or have a fallback mode for drivers that can't actually provide the change blocks but can provide read access to the snapshots. You could still build something that was useful, and then once you have that something, adding in a change block tracking that just gives you the offsets or the file names could be paired with the ability to just read the snapshot to do what you want.
That actually the idea that we have thought about, but we haven't got to the point of sharing it with the community yet. We have to discuss a lot in our next meeting, I guess.
But I mean, it seems like being able to directly read snapshots is way less complicated and controversial than the details of the change block tracking.
Well, actually, not necessarily, right? Then you have pod. Once you have pod includes, then that's actually very complicated, right? I think so far snapshots been simple because you don't have to deal with attaching that to a pod.
Well,
but once we
you're right. To the extent that it intersects with the Kubernetes API,
that's a whole new.
Very complicated.
I mean, yeah, I think we. Yeah. But I think that would need another. It's not. I actually didn't thought this would be required for CVT. I thought this is like one additional feature.
Well, in that case, then the change block tracking has to include not only the what changed, but the data of the change, which makes it a much heavier weight type of interface.
Well, we have the ability to read the snapshot data today. We just have to turn it back into a PV, right? So isn't really this discussion just centered around whether we should provide a more efficient way of getting at the data in the snapshot?
Well, so this one we can definitely talk about it, but I thought, well, not every storage would need this in order to get the CVT. Right, so that's why I didn't really thought this would be. So you are actually thinking this would be a prerequisite almost.
But it depends whether the change block tracking
depending
necessarily
on the
includes the data.
Depending on the source system, I think. But I don't think this is required for every storage. At least I think from our side, I don't think we need that.
So the common the API that currently provided by all the storage vendor that I looked at, the CBT do not contain the data. They only contain the description of the chain, like what block had changed, so on and so forth. They do not including data. Whether it is possible to do that, I think it's totally possible that we can enhance our, to contain
my concern with including the data is that like data interfaces have to be way more performant than metadata interfaces, and I don't know if we want to design like an interface that's actually moving a lot of data around that's based on gRPC, because that might just be a bad way to do
I actually don't. I think I want to avoid that because I don't want to get involved in the. Yeah.
Well, the one more thing is that even though we want to do, including the data or not, it's have to up to the vendor, the storage vendor, to support it, right? And currently, all the vendor that currently support, this type of ABT that exposed to us, do not contain the data. And if we have to include that, we have to.
Why is that required for some vendors? Was that? I mean, I guess I need to understand this one. So from your experience, right? So you said those APIs actually right now, currently that does not include data, and then. But just with that, you will be able to.
Well, the API provide also a way to get the data like for example, if this like VMware, right? VMware's CP, you first you get the chain block, and then you actually get the block in a different core, right? It's just a two different core. I think it's on the same API, but it just do two separate core. Right?
Okay, so you're saying this is still required, basically. A call to get the data is still required, basically.
Yeah, it's not really required for all, but at least it is something that currently in many of the API that
why is not needed? Why is not needed for all? I mean, I guess that part I want to get some clarification.
We need it, right? In what case wouldn't we not need the data? I mean, if you
let's just say if I already have the PVC mounted on my data mover block, I only need then you know I only need to know what block it is then, because all the data is already mounted there. In such case, we don't need to get it directly from the API. I only need to say, you know, 5 blockchain. I have all the data mounted as a raw block on my pod already. So I just copy those 5 blocks. However, if you don't mount that PVC on the data mover, you have some other way, then yes, I agree. At that point, it's better to have that data of the chain available in the API.
I see, and then you have to mount that PV as a read-only if you're creating a.
Well, like I said, there's two possibilities, right? There's 2 ways to do that. I think there's a good point that the data should be available, should be there too. Yeah.
Okay, I think yes. I think this. This is. I think getting to the API design now. Yeah, so we didn't really get to this point yet, but yeah, I think that's actually very important, right? So, yeah, that's really getting to the data path. So that's one reason I'm saying they're not supporting that in CSI. But we can take a look and see exactly what is needed and how to get there. Because I thought in the last discussion, I remember we talked about that. We just providing APIs actually just the control path. So, yeah. So we will need to talk more about this. But I think this is good. 2 more minutes left, so let's wrap this up. So another case we listed here is migration, but this one, yeah, it's not really strictly related to CPT. I think it's just okay, interoperability. Okay, this is like the portability piece, right? Backup from one, restore to another, and auditing. I'm not sure. I'm also not sure what auditing is related to CPT. Anyone want to add something for this 2 use case here? I actually forgot what is this auditing piece. I'm not sure what we'll have this one.
So
here.
in the auditing case, you could just be looking at the stream of files that have changed, and basically getting a report for like security purposes and that kind of thing.
Okay. All right. I think we have 1 minute left, so I think we can wrap up this, and then we can continue to talk about this in another meeting. So going back to this, yeah. So Feng, can you talk about this application workflow in next meeting? Because I was initially going to ask you to talk about this today, but you joined a little late, so.
Yes,
I added the backup and the restore. Yeah, so I think those are good. Yeah, so let's do that next time. Okay, are there anything else? All right, that's it for today. Thank you. Bye.
Thank you. Bye-bye.